Good day everyone, we're going to take a look at the first chapter of the first paragraph of chapter 8, volumes of prisms. And before we're going to discuss what a prism is, I'm first going to take a look at this form right here. Do you still know the name of this 3D figure? And if you know the name, how can I calculate the volume? I think the last question maybe is easier than the first one. In Dutch, this figure is called a balk, and in English we call it a cuboid, right? And we calculate the volume of a cuboid with the formula length times width times height. Lengte keer breedte keer hoogte. We can also state it a different way, right? Because we know that the length times the width is the same as the area of the base. Lengte keer breedte is hetzelfde als de oppervlakte van het grondvlak. So we could also say, well, the volume of a cuboid is the area of its base times height. That's the same as this one. But this formula right here, we are going to use in a way for prisms as well. But before we're going to take a look, do you know any practical examples of prisms without me having already discussed what they are? If I would ask you right now, what is a prism? Which form do you think of? Well, I've just shown you some prisms I've thought of. Right? For example, the form of a Toblerone is a prism. You have prisms like this that they use in physics to refract light. Sometimes, you know, I have studied architecture. You have the forms of prisms in the house. And if you listen to music, well, to good music. This is the cover of Pink Floyd's, one of the albums, Dark Side of the Moon. And you see they used the prism that they use in physics for this picture as well. Really listen to this album, it's a great album. But I digest. What exactly makes a prism a prism? Well, a prism always has two parallel faces. One is called the base and the other is called the top face. Het bovenvlak en het grondvlak. Remember this clearly, the base and the top face don't always have to be, for the base in that case, on the ground and the top face to be the one above that. How can you find the base and the top face? Well, remember all the other faces in a prism are always rectangles. So for example here, this face to the side is a rectangle, this face to the side is a rectangle, here I have a rectangle in the back. Yeah, the other two faces are triangles. That means that must be my base and top face. Here the same. Those faces on the sides are rectangles. I'm left with two triangles. Those are my base and top face. And which one you call the base and which one you call the top face, I don't care that much because they have the same dimensions. But you see that the base is not on the ground here. Here it is on the ground. And how can I find it? Well, it's not a rectangle. Here the base is a trapezium. And the top face in that case as well. Right? The edges that connect the base en de top face are called lateral edges. In het Nederlands opstaande ribben. De ribben die omhoog staan op het grondvlak naar het bovenvlak. Those lateral edges are important because the length of a lateral edge is what we call the height of a prism. You could say that's going to be the distance between the base and the top face, right? And the shortest distance is always going to be perpendicular, so it's always going to be such a lateral edge. Now, what is the volume of a prism? It's going to be the area of the base times its height. That's the same one that I showed you previous slide, right? The area of a cuboid. Only in a cuboid, my base is always a rectangle, so we could just say length times width. Here, my base can be a triangle, it can be a trapezium, can be a parallelogram. I'm going to show you a few more examples of SketchUp in a moment, but what I want to say is how to calculate the area of the base depends on what the form of your base is. Let's take a look at a few extra examples before we're going to continue. I've drawn a few in SketchUp. In all those figures that you see right here, the base and the top face are colored orange. So for example, this one right here is also a prism. All the other faces are rectangles, and the base and the top face in this case are not, and they are parallel to each other. So those must be the base and top face. A normal cuboid is also a special case of a prism, right? So technically speaking, a cuboid is also a prism, where if you want to, you can choose multiple bases and top faces. Here I choose this one and this one, but for example, this face here and this face here can also be base and top face. But normally, if we have a rectangle, we don't have, or a cuboid, we don't have many troubles calculating the volume, because we normally just do length times width times height, which is the same as area of the base times height. So this one here is also going to be a prism, with the base being a triangle and the top face right here. The rest are rectangles. Here is maybe a strange one for some of you, with two trapezia as the base and top face. The other are all rectangles in between. Here the same way, I have a polygon here and a polygon there. In between are rectangles. This one is a prism, some strange polygon on the top and on the bottom with the base and the top face, but everything between are rectangles. And here, this one, of course, in that case as well. You see, all the other faces are rectangles. That's the easiest way to find the base and the top face. If you know what the rectangles are, then you know those are, in most cases, unless you have a cuboid, not the base and the top face. And if you find, for example, two triangles or two trapezia or two parallelograms that are parallel to each other, then that are your base and top face. How can we use this in calculations? Let's continue. So for example, they can give you a sketch like this and ask you to calculate the volume of this prism. The first thing that you have to do in that case is find what are the base and the top face. How can I find those? Well, I think I see a triangle here and a triangle there. I think those should be the base and the top face, and they are parallel to each other. Right, and then for example PQ, CD and GH are lateral edges. They connect the base and the top face, and therefore they are the height. So I already know the height. The height is GH or CD, that's 5 centimeters. But how do I calculate the area of triangle CGQ or DHP? They are the same, right? Please, if you have something like this, give a sketch of the base. So for example, here I would sketch, let's see what the book does. They use ADHE. You could also have used BCGF. They use the same dimensions. They sketch it because this gives me a lot better view of what I have to do. What example am I calculating? And how am I going to calculate it? So here they sketched AD. They know that that's free. It's given, right? The same as BC. I know that from A to E is 4 centimeters because that's CG. And I also know that AP is 3 centimeters, right? So here, how can I now calculate PDH? Well, you can use two different ways. Sometimes it's easier to calculate the area of the triangle itself, and sometimes it's easier to take the area of the rectangle and subtract the pieces that are not part of it. Here, it's easier to in one go calculate the area of DHP. What was the formula for the area of a triangle? It was a half times the base of the edge, sometimes they call it the side, half times the side times the matching height. So here, area of the base, and then they mean, in this case, PDH, is a half times side 4 times its matching height is 3. Remember, the matching height is always perpendicular on the side. So that's the area of my base. Then what's now going to be the volume of this prism? Well, I already spoiled the height. The height is this lateral edge, right? It's PQ or GH or CD, that's 5. Then now the volume is just the area of the base times its height. So it's just going to be 5 times 6. And this one we need here is from a different exercise. You don't have to view this. We stop here, 30 cubic centimeters. Please, we're working with volumes and areas again. In your final answer, write down your units. In this case, cubic centimeters. Okay? Let's try another one. This one. Here, my base is ABKL. Why? Those are not rectangles. Here, AL, ME, and all the other ones are rectangles. So I know my base is ABKL. So I make a sketch of my base with a rectangle around it included. Then I write down all dimensions that I know, so I'll label my drawing. And here, I think, as I already said in the previous exercise, it's a lot easier to calculate the area of the white parts and subtract them from the total rectangle. The total rectangle is 5 times 3. The area of 1 is a half times the side times its matching height. Because those are right angle triangles, you can just do a half times 2 times 3, right? Because here is a right angle. Here it's a half times 1 times 3. So it's going to be 15, 3 times 5, minus this thing, that's going to be 3, and this thing is going to have an area of 1.5. And I find the total area of ABKL is 10.5 square centimeters. What is the height? Yeah, that's going to be the distance between the two, between the base and the top face. A and E, difference between those two is 4 centimeters. That's going to be the height. So the total volume is going to be 10.5 times 4 is 42 cubic centimeters. Again, please write that down. So I now gave you 2 different examples of those volume calculations. I will do a separate video about maybe a few from exercise 2 as well. Please try them first by yourself. If you have troubles, please watch my other video. I use SketchUp in those videos to also rotate around those 3D shapes to give you a better insight on what we're talking about. Good luck, and remember, if you have trouble, watch my other explanation video as well.